Hello dear students, welcome back to NEET World. So today in this session we will be discussing like very important 2 marks question from Electrochemistry and Chemical Kinetics chapter. So I will be taking almost around some 15 questions. So out of these 15 questions you can expect one question as a 2 marks question from this Electrochemistry and Chemical Kinetics chapter. Okay, so let's begin our session. Yes, before that, see, this is our C60 material. So this is specifically designed for IPE students who are aspiring to get 60 out of 60 in their IPE exams. Okay, right. So now you can access this material for free of cost from our NEET World app. Okay, so just go to Play Store and download NEET World app. Okay, then log in using your mobile number and mention your class and group in the chat box. Then our team will guide you how to access this material for free of cost. Okay, right. Let's move forward with the discussion of our topic, that is a 2 marks question from Electrochemistry and Chemical Kinetics. Right. Now if you open the material, you are going to see the interface like this. Okay, so this is the book PDF here I am showing you. So from this we have provided for each chapter important questions, something like maximum of some 10-15 questions maximum in 2 marks. Okay, so out of that you can expect a question. Okay, like that we have designed it for all 2 marks as well as 4 marks and 8 marks from each chapter that are prescribed in the IPE syllabus. Okay, right. So yes, here if we see Electrochemistry and Chemical Kinetics, first of all you need to know that from this chapter there will be one 8 marks question for sure, and if you haven't watched that, you please go and watch it after this discussion. Okay, I already covered 8 marks question that comes from Electrochemistry and Chemical Kinetics, and it will be there in the playlist of this channel. Just go and watch it. Okay, that is for LAQ, 8 marks. Okay, and one more chapter is P block where we can expect the 8 mark question, and one more is from organic chemistry. Okay, so all these 3 LAQs are discussed already. Now this is the time for 2 marks question here. Already 4 marks questions are also almost over. Okay, right. So now if you look, the first question here is state Faraday's first law of electrolysis. Okay, this is the first question here we have. Right. Right. Yeah, so let me zoom it. So read the question now. Now it's clear, I think so. Yeah. So question says state Faraday's first law of electrolysis. So what is the first law of electrolysis? Faraday's first law of electrolysis. It's very easy. See, what do we mean by electrolysis? See, I will tell you a simple way in our general terms, in our daily usage terms, so that you will be more connected to the discussion. See, for example, if you take salt water, what it contains? Sodium chloride, right? So from this sodium chloride, see, sodium chloride is a natural substance, like naturally occurring material, like a salt form which is appear in the sea water, like that right now. So now from this I wanted to extract chlorine. What I want to extract? Chlorine gas. See, we have chloride ions in the NaCl. This is a naturally occurring substance. From this I want to extract chlorine gas. So now what I need to do? Chloride ion should convert into chlorine gas. See, if I take 2 chloride ions, we are going to get 1 chlorine molecule. So during this transformation, it is releasing 2 electrons. See, whatever the transformation we are seeing here, it's a non-spontaneous process. See, we know NaCl occurs in the nature. Okay, it is available in the nature. So from that I want to extract this chlorine gas. Okay, for that purpose I need to convert the chloride ions from this NaCl to chlorine. So this conversion requires some energy, okay, or some electricity. So now some electricity, by passing off some electricity, we are converting chloride ions to chlorine gas. So this process is called electrolysis. What is this process called? Electrolysis. So not only this, from any natural sources we can able to prepare our desired material from respective sources. Okay, like that. Okay, that process, whatever the electrochemistry process we are using, that is called electrolysis. Okay, I hope you got some clarity what do we mean by electrolysis now. Okay, now listen here what they are saying. Now what is the quantity of this chlorine deposited during the electrolysis depends upon quantity of charge we are passing through this electrolytic solution. So this is what the Faraday's law says. So what I am saying, the weight of substance, see, it is not only chlorine, it can be any substance. The weight of substance deposited, okay, will be directly proportional to quantity of electricity or quantity of charge passed through that electrolytic solution. Since this is an electrolytic solution, we are passing electricity through it. So now what happens, at the electrodes we are going to get the substance. Now weight of substance deposited at the electrode depends on quantity of electric charge or charge we are passing through this electrolytic solution. So this is what the first law of Faraday's first law says. Okay, right, listen this once again, read the statement. Okay, see, the Faraday's first law states that the mass of the substance liberated or deposited at any electrode depends during electrolysis directly proportional to quantity of electric charge indicated with Q. Okay, quantity of electric charge passed through this electrolytic solution. So weight is directly proportional to Q, I can write. Okay, now what do we mean by Q? It's a charge, that is current into time. Okay, so for current like charge units are coulomb. So coulomb is equals to I into S, I mean amperes into seconds, coulombs means. Okay, so now I can remove this proportionality and I can place a constant here. So mass of substance or weight of substance deposited will be directly proportional to Q, I am writing now. So weight is equals to ZQ, I can write. So Q means charge into Q means charge. So charge is nothing but I into T, that's it. So here Z is the electrochemical equivalent here. Okay, Z means what? Electrochemical equivalent. When we removing proportionality, we can insert that. Okay, so this is what the first law of Faraday says. Okay, hope up to here the discussion is clear. Now during exam, in the competitive exams like NEET, JEE and EAP set, we can expect questions directly related to this formula. Okay, so this is a 2 marks question for your IPE. Now you can slowly interlink this to some numerical based questions that comes in your competitive exam. That's it. Okay, do not think that IPE preparation is different and your competitive exams like EAP set preparation is different. No. So try to learn the concept here and apply that in the questions, in the numerical based questions. That's it. You are going to do the both preparation simultaneously. This is how you need to make your preparation for the competitive exams. Okay, along with your IPE. Okay, right. Up to here it is clear now. Right. Let's move forward. We'll see some numerical questions on this later. But let's move forward now. What is the second question says? State Faraday's second law of electrolysis. This is first law. This is second law. Now if you see, what second law says is, see what I told you, we are taking electrolytic solutions like this we are taking now. So here I used only one electrolytic solution. Now here I am using some electrolytic solution. This is 1, 2, 3 like that. We can use n number of electrolytic solutions. Now what I am doing, I am passing Q amount of charge. What I am passing? Q amount of charge. It means same amount of electric charge is passed through this solution 1, electrolytic solution 2 and like solution 3 like this, which are in series connection. See, when the same quantity of electric charges passes through different electrolytes, the masses of substance deposited, it means what is the mass of substance deposited from this electrolytic solution 1, electrolytic solution 2 are directly proportional to their chemical equivalent weight. The mass of substance deposited in one is directly proportional to its equivalent weight. For example, here I am taking copper sulfate. So the weight of copper deposited will be proportional to equivalent weight of that copper. Plus 2 ion. Okay. So like this we need to write. So here you can see. So mass of electrolyte deposited 1 is proportional to its equivalent weight of that substance 1. Okay, so here also mass of substance deposited in this electrode in this electrolytic solution can be like M2 is directly proportional to its equivalent weight. Okay, E2. Okay, like that. If you take the ratio of these two, you are going to get mass of 1 by mass of 2 is equals to E1 by E2, equivalent weight of 1 by equivalent weight of 2. Slowly, this is how you need to do. Okay, hope the discussion is clear. Right. So for example, in the solution in this one, I have copper sulfate solution. Okay, I have copper sulfate solution, let us say, and here I have AlCl3 solution. Now the quantity of copper deposited, the mass of copper deposited by mass of aluminium deposited will be equals to equivalent weight of copper by equivalent weight of aluminium. Like this we need to write. Okay, so here equivalent weight means atomic weight of aluminium by 3. Okay, and here copper, atomic weight of copper by 2, because n factor here is 3, right? So like that we need to take. Anyways, this extra discussion is not required for your IPE exam point of view, but it is required if you are writing any competitive exam. But I hope you got that concept that when you pass same quantity electricity, okay, the weight, the mass of substance deposited at this electrode and in this electrode and at this electrode are directly proportional to their equivalent weights. Okay, if I consider 2, m1 by m2 equals to e1 by e2, that's it, where e1 e2 represent their equivalent weights, m1 m2 represent their their weights of the substance deposited. That's it. Okay, that's it. So up to here it is clear now, right? Let's move forward with the third question here. Right. So the third question here we have is, what is galvanic cell? What is galvanic cell? They are asking. Okay. So what is galvanic cell? Give one example. A galvanic cell is an electrochemical device that converts chemical energy to electrical energy. What it will do? It converts chemical energy to electrical energy. So this is what the galvanic cell do. Okay. Right. So now this process, whatever the electrochemical cell device we are using, whatever the cell here, the chemical reaction takes place spontaneously. See, a galvanic cell in which the electrochemical reaction takes place. It means galvanic cell is an electrochemical cell, okay, in which a spontaneous chemical reaction takes place that produces electrical energy, or you can write as it is. See, a galvanic cell is an electrochemical device that converts chemical energy into electrical energy through a spontaneous redox reaction. It means a spontaneous redox reaction takes place in that cell that produces electricity. That's it. This is what the galvanic cell do. Okay. So for example here, copper sulfate is there, Zn and ZnSO4. So let me write the reaction. See, zinc plus copper sulfate if you take, now what happens is this zinc spontaneously undergoes oxidation when you react with the copper sulfate solution. So it becomes zinc sulfate and copper metal is formed. So now what you are seeing here, so +2 ion, copper +2 ion, see, copper +2 ion converted into 0 oxidation state, zinc 0 converted into Zn+2. So what is happening from here to here? Oxidation taking place. What is happening? Oxidation. From here to here, reduction. Okay, so this is how a chemical redox reaction takes place in a spontaneous redox reaction takes place in the electrochemical cell that produces electricity. That's it. This is what happens in electrochemical cells or galvanic cell here, I can say. Okay, right. So this is how you can represent first oxidation reaction, salt bridge, then reduction reaction. Okay, next, define order of a reaction, give one example. What do we mean by order of a reaction? Give one example. Okay, it's easy. See, order means it's an experimentally determined quantity. See, for example, there is a reaction, substrate or reactant are giving some products. Okay, so now rate of a reaction, okay, let us say A is a reactant converting into some product. So rate of a reaction directly proportional to concentration of this reactants here. So A to the power m. So this m is called order with respect to this reactant. Okay, see, order of a reaction is sum of powers of concentration terms of reactants in the rate equation or rate law. For example here I am writing one more thing. Just see, A plus B giving rise to some products. Now what is the rate of reaction? You can write rate is directly proportional to concentration of A to the power M and concentration of B to the power N. So here M, N are there now, those are called orders with respect to A and B. Okay. Now the total order of the reaction will be equals to M plus N. So M plus N is what? The total order of the reaction. Okay, right. So now here they have represented a reaction. So NO, 2NO plus O2 gives rise to 2NO2 they are writing. So now order with respect to NO is 2 and with respect to O2 is 1. Okay. So here rate equation can be written as K into concentration of NO to the power 2, O2 to the power 1. So now what are the total orders? So you just add these two terms, 2 plus 1. Okay, right. So for this reaction you can see stoichiometric coefficients are becoming their order, but it won't be the same all the case. Okay, only for few cases it will be work. Okay, because order of a reaction determined experimentally, it is not given theoretically. Okay, right. So by looking at the experimental data only we can estimate the order of the reaction. Okay, right. Let's move forward.
It contains ribitol, or we can call flavin.
Yeah. So what is next? Here give two examples of gaseous zero order reaction. What they are asking? Give two examples of gaseous zero order reaction. So for example, if you take the decomposition of ammonia over platinum catalyst can be considered to be a zero order reaction. See, ammonia decomposes to give N2 plus 3H2. Okay, so this decomposition happening at the platinum surface. Okay, so this decomposition reaction is an example of zero order reaction. Okay, just now I told you order of a reaction can be determined experimentally, not theoretically. Okay, so this is an example you need to remember. Next, thermal decomposition of hydrogen iodide Hi over gold catalyst. Okay, so see, Au, gold is a catalyst here, so 2Hi giving rise to H2 plus I2. Okay, these are the two examples you can remember for zero order reaction. Okay, right. Then next here, what are pseudo first order reactions? Give one example. See, pseudo first order reactions means see, you just read this. A pseudo first order reaction is actually a multi-molecular reaction that behaves as a first order reaction because one reactant is taken in large excess. See, generally there are some reactions. At normal states they might be second order, third order also, but when we consider the concentration of one reactant as an excess quantity, okay, and other reactant as a normal quantity, now what happens? The order with respect to that excess quantity is negligible here. I mean, no need of considering that. Okay, so the one which is defining here is the other one. So see, those reactions in which molecularity is a multimolecular but order of the reaction is first order, then they can be considered as a pseudo first order reaction. See, a pseudo first order reaction is actually a multimolecular reaction that behaves like a first order reaction because one reactant is taken the large extent. See, for example, sucrose is there. Okay, sucrose means cane sugar is there now from that. Hydrolysis of cane sugar in acidic medium. See, sucrose is there here. And what contains riboflavin? So, will be what is here? It means it is depending only on this sucrose because what is taken in excess amount. So now rate of reaction can be written as these are two reactants now. So rate is equals to K constant into concentration of sucrose into concentration of water. But what I told you, the order with respect to this excess quantity reactant is 0. Therefore, you need to depend, now the rate of reaction depends only on sucrose concentration, right? So now what happens, term 1 will be there, N equals to 1, its order equals to 1. Okay, right. So molecularity will be more than 1 but rate of the order of that reaction is 1. Those are considered to be pseudo first order reactions. Okay. Now here the next question, let me show you the next question. Give the units of rate constant for 0 order, first order, second order reaction. See, I will tell you one simple way to identify this unit rates, rate constant units. Just follow this step. Okay, just use this. It is useful in your competitive exams also. Say like concentration to the power 1 minus n, so time inverse, that's it. This is the thing you need to remember. So what is this n indicates? N indicates order of the reaction. So it is applicable for all types of orders. Okay, order of the reaction. Okay, order of that reaction. For example, here they are saying 0 order now, so put n value 0. So if it is n value 0, concentration to the power 1 minus 0, that is 1, time inverse. So concentration is given as a mole per liter, that is mole per liter, time is in seconds, so second inverse. Okay, this is for 0 order reaction. This is for which order? 0 order reaction. Okay, similarly for first order reaction, what you can say is n value should be 1. First order I am saying now n value is 1. So concentration to the power 1 minus 1 is 0. Something power 0 is what? 1. Okay, then this term becomes 1. So time inverse only the unit we are going to have for first order. That is, let us say it is in seconds. So second inverse is a unit for first order reaction. See, for 0 order, mole liter inverse, second inverse. For first order, just second inverse. Now for second order, you tell me. So n value is 2 now. So what happens, tell me? Concentration to the power 1 minus 2 time inverse. So concentration to the power minus 1 time inverse. So concentration to the power minus 1 means what? So concentration, that is nothing but molarity, that is mole per liter to the power minus 1, and time inverse. So mole to the power minus 1, liter to the power minus 1, it becomes plus 1. Okay, and time inverse, that's it. So it means mole to the power minus 1, liter inverse, second inverse, liter power 1, second inverse. So here we have mole to the power minus 1, mole inverse, liter, second inverse, that's okay. This is the units for second order. Now tell me, what are the units for third order reaction? If n equals to 3, what are the units we are going to get for a rate constant? Okay, what are the rate constant units for third order? I am expecting that answer from your side in a chart box. Okay, you just try using this, you are going to get the exact answer. Okay, just tell me. Okay, the next, what is metallic corrosion? And give one example. See, metallic corrosion means it's nothing but metal undergoing oxidation, that's it. Remember, metal undergoing oxidation to form metal oxide, that's it. Okay, see, metallic corrosion is gradual destruction of metal by chemical reaction with moisture and oxygen in the environment. So it means what? For example, iron is there, so iron will form iron oxide, that is nothing but Fe converts into Fe2O3 dot XH2O. Okay, that's it. So this is called rust. What is the formula of rust? They will ask. Fe2O3 dot XH2O. In case of metallic corrosion is nothing but the gradual destruction of metals by chemical reactions with moisture and air in the atmosphere or in the environment. That's it. Next, give the cell reaction of nickel cadmium secondary cell. Okay, so batteries, one of the important topic for your competitive exams. Anyways, you can remember this equation for this nickel cadmium secondary battery. Okay, so what are the differences between, again this question also we can expect, what are primary cells, secondary cells, what makes the difference between them? Okay, so right, so this is a secondary cell. So cadmium plus nickel trihydroxide gives you cadmium oxide plus nickel dihydroxide and water. Remember this reaction. Okay, right. So the next one here, how is change in Gibbs free energy related to EMF of galvanic cell? How is change in Gibbs free energy related to EMF of galvanic cell? Formula can be taken as delta G naught is equals to minus NF E naught cell. I will tell you. So Gibbs free energy delta G is nothing but maximum work done. Okay, maximum work done by the system we can say. So now work done can be given as a charge into potential. So now what is the charge here? So Faraday's charge is given in terms of Faraday. So that is a charge in coulombs for 1 electron, you get 1 mole of electron like this. If there are n moles of electron, you should take it as NF. So this indicates charge into potential, right? So potential is indicated with E cell. Okay, cell potential I can say, EMF or cell potential I can say. Now here, since it is a work done by the system, you should indicate negative side. So you can say delta G is equals to minus NF E naught cell. So where N represents number of electrons, number of moles of electrons participated in the reaction. Okay, and F represents number of Faradays. It means charge of, F represents Faraday. So what do we mean by Faraday? It is a charge, like charge of 1 mole of electrons. What is the charge of 1 mole of electrons? It is approximately 96500 coulombs. Okay, 96,500 coulomb per mole. Okay, for charge of 1 mole of electrons, you can say. And E means E cell, that is EMF of cell. That's it. That's it. So this equation shows if E cell is positive, delta G reaction is spontaneous. See,
glycogen
this process, delta G must be negative. In order to make delta G negative, see, E cell has to be positive. Already we have a negative sign here right now. So if E cell is positive, then delta G is negative, then the cell will be a spontaneous cell. Now E cell is negative, delta G becomes positive, that is a non-spontaneous reaction and non-spontaneous cell. Okay, like that we can identify spontaneity of a cell reaction. Next, here, the 11th question says, a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. Find the mass of copper deposited. Okay, so what is the quantity of copper deposited here? Yeah, the first question that we have studied now, based on that you can say. So what I told you, weight of a substance deposited is directly proportional to quantity of electricity passed through the electrolytic solution. Now you can write this as weight is equals to Z into I into T. So what is Z here? So electrochemical equivalent, that is the ratio of equivalent weight to the number of Faradays. Okay, I into T, that's it. So this is what you need to take, and if there is n number of electrons involving, you can take n. Okay, that's it. So here copper plus 2 now. So copper plus 2 converting into copper. So how many electrons are involving for 1 mole conversion? Plus 2 is converting into 0 means 2 moles of electrons. For 1 mole of copper, 2 moles of electrons are required. So n factor here is n is 2. Okay, that's it. So right. So now here, wherever we have equivalent weight, you can write its molecular weight by 2. Okay, so that is nothing but here weight. It means you just write it as like this you can write. So weight of substance deposited will be its atomic weight into I into T by NF I am writing. So atomic weight of copper is how much? 63.5. Okay, into I will be how much? 1.5 angstroms multiplied with the time for 10 minutes. You should take it in seconds. So 10 into 60 seconds you can say by N. What is N here? How many electrons are involved? 2, and Faraday's is 96500 coulombs. Okay, so ampere, seconds, coulombs are removed. So you are going to get the weight of substance in grams. Okay, now what is the weight of substance deposited? 0.296 will be your answer for the question. Okay, right. Is this clear? Yeah, let's move forward. The second question says, 12th question here, it says the reaction has the half-life of 10 minutes. For a first order reaction, what is the half-life? 10 minutes. Now find the rate constant for that first order reaction. Okay, so it's again easy. There is a direct relation between first order T half and its like time required for completion of half of the reaction, that is half-life of the reaction, that is T half is equals to 0.693 by K. Okay, so 0.693 by K. So I want to find the insulin. So what I can make from here? So K is equals to 0.693 by T half. T half, that is 0.693 by 10. So you can say this is 0.0693 minutes inverse, minute inverse. Okay, that's it. That is your answer. Okay, now sometimes they may also ask you what is the integral equation for first order equation. See, you can use this. T is equals to 1 by K log, here you can say 2.303 log initial concentration of reactant A, let us say, and at some time t concentration is A minus X for the reactant. Okay, this is the formula to be used for calculation of time or rate constant or concentrations after remaining after time t, like that we can use. This is an integral equation. Since here half life is asked, this is perfectly done. This is an extra point I am just adding for your information. The next here, 2 more questions are there from the chapter. For a first order reaction, rate constant is given as 5.5 into 10 power minus 14. Find its half life. Yes, it's very easy. The way we have did in the previous question, we follow the same steps. See, they are asking half life. T half is equals to 0.693 by K. What is K here mentioned? 5.5 into 10 power minus 14 second inverse. So I am writing second in the numerator. So on simplifying this, you are going to get 1.26 into 10 power 13 seconds. That will be your answer for the question. Okay. See guys, why I included this kind of questions, because these are previously asked questions. Okay. For IPE exams, we should not skip the previously asked questions, right? So that's why first focus on the questions that are asked in the previous exams, whether it can be 2 marks, 4 marks, 8 marks. Then if you have time, you just focus on other questions. First cover the previously asked questions, especially for your IPE exams, okay, board level exams. Okay, the next question here, the standard EMF of Daniel cell is 1.1 volt.
Because glycolysis is what reaction?
Change for this cell reaction. Okay, so what we are saying, standard EMF of Daniel cell is this much. So E naught of that cell is this much. Then find the Gibbs free energy stream. Find the standard Gibbs free energy. Just now I told you the formula. So what is that formula I have given? Delta G, let me write this. Delta G is equals to minus NF E cell I have given. This is Gibbs free energy. Now they are saying standard Gibbs free energy now. So take it with a standard cell potential. That's it. So standard Gibbs free energy is equals to minus Daniel cell, here electrons are 2, okay, Faraday 96500, and into this one 1.1 volt. So that is, see here Daniel cell is nothing but that copper and zinc reaction only, that whatever we have used, okay, copper plus 2, it is zinc, this reaction only. So this gives you energy like coulomb into volt you are going to get, okay, so that it will be in joules now. Okay, so upon simplifying you are going to get like this, see, minus 2 into 96500 into 1.1. So it is something like this. You can write it as 1.1212.3 kilojoule per mole. So this is what the final answer. Okay, so remember coulomb into volt can be written as joule. Okay, that's it. So these are the things to be remembered, and you need to practice on these questions first from electrochemistry and chemical kinetics for 2 marks. Okay, I hope this session is really helpful for your IPE preparation. Yes, if you really like this content, please share with your friends and you just click on the like button. So thank you for watching. Stay connected with our NEET World YouTube channel.